Okay. Uh, the Jamboard is visible to you, right?
Yeah.
Um, okay. Hello, everyone. Welcome to Fundamentals of Electrical Engineering course of NPTEL. So today we will be solving a few of the questions, and if you have any doubt in the lectures, you can ask during this time. So just for a quick warm up, we will try one very basic question, which is like the question is given of it goes like this. It is of there is a wire of radius area A and diameter D, and the length is L. So sorry, the wire A is of diameter D and length L, and the resistance is rho. There is another wire of diameter 2D, the length is 2L, and specific resistance is 2 rho. So you have to find the relation between resistance of B and resistance of A. So anyone wants to go ahead how to solve this?
So the we know this rho is R is equal to rho L by A.
Right,
So we'll just take RB by RA is equal to we'll substitute those values in RB as 2L, 2 rho, and 2D.
right.
Basically, area is pi into D, right? So
Yes,
diameter will be 2D for resistance B, and for resistance A, it will be same as D.
right. So let's try and solve this. So we know R equal to rho L by A.
Yeah.
And for R A, like for the wire A, it is given as resistance is rho, length is L, and diameter is given. So pi d by 2, it is R square, so d by 2 whole square. So it is basically 4 rho L by pi d square. Then for the second one, RB, same thing goes. Here the resistance is 2R. Let Okay. So just a quick reminder, guys. Join on time, otherwise it will be difficult. Um, okay. So for for the wire B, the length is given as 2L and diameter is given by 2D. So radius will be D. So it is pi d square, which is again 4 rho L by pi d square. So the option which will be, since both the values are same, the correct option will be option D. I hope everyone has followed. If not, you can ask. So we will move to the next question. You're given a circuit, you have to find the input resistance. This is kind of an infinite circuit, that is to say, beyond this point, again there will be a resistor of 2 ohm here and another resistor of 2 ohm, and this continues. So, can you guys please try this one out? Can you guys try this out and come up with the answer? So I'll just call up someone maybe. Um, Gaurav, am I audible to you?
Yes, ma'am, you are audible.
Okay. Do you would you like to try this problem? How would you solve it?
Ma'am, same question we done before in. Previous lecture.
Okay, there was one interaction session before this.
Yes, ma'am.
Okay, then let's move to other questions. So you guys have done this, all these questions, right?
Yes, ma'am. Up to the 10th question, ma'am.
Okay, let's then start from the 11th question. So this one you have done?
No, ma'am. No, ma'am.
Okay. Then let's look into this question. um, like in a cyber cafe, there are lots of components, such as there are 6 lamps of rating 20 watt, 4 fan of 75 watt. Similarly, there are computers and air conditioners and printers. uh, like the cost of meter rent is given, and if it is said like 50% of loading is there throughout a day, what is the bill for the month of June? And we have to like assume the cost of first 800 unit is given, then the next 500 unit is given, and after that, beyond that, the cost is 6 per unit. So can you guys try to find out the total cost, like total bill of the month of June? So first, what you have to do, anyone wants to go ahead and answer? First, what do we have to find out? um, Hardik Patel, could you try? The load is given, right? What, how is our like our billing done? Like it is done on energy, isn't it? So what do you have to find out? Can
Ma'am,
anyone?
electrical energy.
Sorry.
Ma'am, we have to find electrical energy.
Yes. So how will you calculate that? Initially you have to calculate all the consumption by each of this load, right?
Yes, ma'am.
Yeah. So could, could you guys try this one? So first step is calculating the total consumption. So there are 6 lamps of 20 watts each, right? Plus 4 fans of 75 watts. Then there are 10 computers of 150 watts. 2 air conditioner of 1500. Then there is 2 printer of 40 watt. So when you do a total of all this, it comes out as 5000 watt. Now, is the entire whatever rating is given here, is it entirely used throughout the day? What is given in the question? Could you say? Um,
Like only half of it is being used.
right,
It's 50%.
right.
So 2,500 watts, and for that we'll calculate the cost
Yes,
according to what is given, like 800 units 4 rupees, next 500 rupees, 500 units 5 rupees.
right.
Probably we'll get a cost range from that.
Yes. Could you like finish off the problem and let me know which option is correct? So this energy is power into time, right? And we know
Yes,
like
ma'am.
50% of this is consumed, so it is 2500. So what will be the time? Anyone else would like to try? Please unmute and speak up.
Ma'am, 24 hours.
Yes, it is for one day. What do you have to
Into
calculate?
30 days.
Right. So it will be 24 into 30. So it comes out to be as 1800 into 10 to the power 3, I guess. Yeah, 1800 kilowatt hour. Now the billing is done on the 1 unit of kilowatt hour, right? So for the first 800 units, it is given as 4. So it will be 4 into 800 plus for the next 500 units 500 into 5, and the remaining, so 800 gone, 500 gone, remaining 500 is left, 500 into 6. So which
Ma'am,
are, yeah.
ma'am, what is unit?
So like 1 unit in like whenever we do a billing for meter, so 1 unit means 1 kilowatt hour. Okay, because this is the
1000
unit.
watts.
Okay, anyone is trying to say something?
Ma'am, continue.
What is it?
Continue, ma'am.
Okay, so yeah, so and there is a meter rent charge given here, so it will be plus 150, right? So can you calculate what is the answer?
Option D, 8008.
Yes, so it is 8850, right?
Yeah.
Okay, I hope it is clear to everyone. Let's move to the next question.
Ma'am,
Yes.
ma'am, previous question, the last line, assume cost per unit, ma'am. This line, I don't get it. Can you explain it again?
This one, assume cost per unit for the first 800
Yes,
units
ma'am.
be. Okay.
Yes, ma'am, this line.
So in power sector, the billing is done for 1 unit means 1 kilowatt hour. Okay. Now your consumption has been 1800 kilowatt hour. 1800 kilowatt hour. Now see, because in power sector, the more you consume energy, the higher your bill will be. But if it was an uniform unit, then the revenue of the power sector would not be that good. So what they do is, like up to a certain unit, suppose out of this 1800, I can write it as suppose 800 plus 500 plus 500, right? Now, these 800 first units which you consume, the cost is given as rupees 4. Then, when your 800 units has been passed, the next 500 unit, the cost is rupees 5 per unit. Then beyond that, how much bill it would be? Right now, here it is up to 800 watts. So 800 plus 500 is 1300. Then the remaining 500 will be charged as rupees 6 per unit. If it was like another 1000 units, even those 1000 units would have been charged rupees 6 per unit. So that way you have to calculate. So first for 800 units, rupees 4 multiplied by 4. Then the next 500 units is 5 rupees per unit. The next 500 is 6 rupees per unit. And this is the constant meter rent that is given here. Did you get
Clear,
it?
ma'am.
Yeah. Okay.
Yes, ma'am, I get it.
Okay. Okay. Let's move to the next question. So anyone else could you comment like whether these statements are true or false about the first statement? uh, Hardik. uh, Someone's mic is making a noise. Hardik, could you like not unmute? Anyone would like to try? The first statement, is it true or false?
Ma'am, true. No, ma'am, false, false.
Not only for linear networks, like it is true for other networks, so this is not right.
Yes, ma'am.
Then Ohm's law.
Ma'am, what is lumped elements?
Okay, so lumped elements are basically, see, you know, could you not, whoever is like switching on their mic, please don't. We are getting a static noise. Hardik, please don't switch on your mic. Hardik, if you can hear me, please don't switch on your mic. Yes, sorry, we had to do that. So, so for the lumped parameters, like if the size of the element, uh, somebody is entering again. Okay, so let's go back. Uh, for the the for the second statement, you know, when the size of the element is smaller than the wavelength applied, it is called as lumped element. So for example, RL, resistance, capacitor, inductor, all these are called the lumped element. So Ohm's law is not just specific to this lumped parameters, right? Did you get it?
Ma'am, I don't get it. No, ma'am. Once again, what is lumped elements?
So basically, lumped any lumped element, like whatever it might be, it is corresponding to a very, small, it is, if the size of the element like is smaller than the wavelength of the signal applied. Here the signal applied will be the voltage, the current, any other signal. Those kind of elements is called lumped element. Example of lumped element I could give as resistor, then capacitor, inductor, etc. These are the lumped elements. I mean examples. Ohm's law is an
Okay,
universal
ma'am.
law, not specific to these, right? It is an universal law. So this only word makes this statement incorrect. Okay. So, could anyone comment about the
Okay,
third
ma'am.
statement?
Yes, ma'am. It is only valid at constant temperature.
Exactly. So, this
It's true.
is true. So, that way, only option is true. Option D is true. Okay. So, we will move now to a few other questions. Uh,
No, ma'am.
okay. So, can someone comment on this? Like, could you comment whether these connections are valid or invalid? Let's go with the first one, A. Is this connection valid?
Yes, ma'am, it's valid connection.
Could you comment why?
Ma'am, because both the voltage sources are same and connected in parallel.
Right. So they are connected across this terminal, and since they are connected in parallel, their voltage is same. How similarly for B, it is exactly the same, right? The current source are
Yes,
connected in series, so they are same. What about C?
ma'am, it's invalid connection.
Right, because the voltage magnitude are different. So does D, invalid. How about E? Can anyone
Ma'am,
comment?
invalid connection.
Okay, why do you say so?
Because ma'am, there is no load connected in it.
Yeah, so this is a short circuit kind of a thing, right?
Yes, ma'am.
So
Maybe.
so in short circuit there is like slight resistance of the wire. So in short circuit what happens? We get a very high current, right?
Yes, ma'am.
So option E is actually valid. Anyone disagrees?
Ma'am, but here load is not connected. So
Yes.
why?
So this is short circuited, right? Imagine like this was the output terminal. It has been short circuited. If there is open, if this one had been like this, suppose there is a voltage here and there is an open circuit, then current wouldn't have any path to flow, right? But if this one is
Yes, ma'am.
short circuited means a very high current will flow through it, because r is almost like tending to zero. Only the resistance present is the resistance of this wire, no, since no element is present.
Clear, ma'am.
Yeah.
I understand.
Okay. Anyone else has any other question? If not, then we can move to the next one. Okay. So in this question, at at any time greater than 0, the charge equation is given. You have to determine the current. So how are we going to solve this? Can anyone suggest?
Differentiate with respect to time.
Right. So current is given by dq by dt. So can you quickly solve like the question? So basically you have to determine the current at time, a specific time that is given. So can you quickly solve this and let me know the answer? So dq is 0.4. Different on differentiating this part, what do we get? The first one is a constant, The second one is 250, right? So e to the power, suppose there is a into x. So differentiating that is e to the power ax, right? So it is 100 into e to the power minus 250, right? So what is the answer at 3 millisecond?
47.23.
Yes. Anyone has any doubt in this question? Okay. If not, we'll move to the next question.
Ma'am, the current, the unit comes to ampere, right?
Yes.
Or milliamperes.
Sorry. Yeah. Since it is given millicoulomb here, so this unit is millicoulomb, milliampere, right?
Okay. Fine.
Because the millisecond that is in this power, so 250 times t, it is not t is not multiplied anywhere here, right? So the current will be milliampere.
Okay.
Yeah. Anything else about this?
No, ma'am.
Okay. So now a certain uh, a circuit element has a current given here and a voltage given here. You have to find the total energy transferred at time t greater than equal to 0. So how are we going to solve this?
We'll multiply I and V and integrate it with respect to T. We'll get energy.
Yes. Energy equal to integration P dot dt. Here P is the power, which is VI. V into I. Can you guys solve this and tell me the answer? So anyone apart from Bharat, can you please try this? If you have any doubt, you can ask right away. Anyone facing any problem, you can speak up and ask, okay? This will be the integration, right? So, what will be the limit of the integration? Um, could Rohit comment on this? Rohit, could you comment what will be the limit of this integration? You can speak up. You might be correct or wrong. It doesn't matter. You will have to speak up because this is the interaction session, right? Rohit, can you unmute and speak up? Okay, maybe anyone else?
0
Ma'am,
to
zero to
infinity.
infinity. Zero to
Yes,
infinity.
yes. So when you solve this integration, what is your answer? Could you let me know? Um, Apart from Gaurav and Bharat, anyone else please try? Raja, am I audible to you? Rupali, could you unmute and like say if you're having any problem? So, okay, I see. Okay, then just whoever finishes off, please let me know.
I think it's 0.05.
0.05. Yeah,
I got that.
yes, you're right. Anyone else got the same value? See, guys, you really have to speak up because I'm not your professor, right? You can be wrong or right. Anyone has any doubt in this question? If not, then we can move to the next question.
No, ma'am.
Okay, okay. So for the other question, so you have a circuit. Each the load across each circuit is given. You have to find Vx. So this is pretty straightforward. Can you and also yeah, the power delivered to like you have to find the voltage Vx and the power delivered to this particular element. So how will you solve this question? Please someone else speak up. Just try. Twing.
Ma'am, we will apply.
Yeah, Anand, go ahead. Yes, go ahead. Anand, you're muted in case you're speaking.
I'm trying. Solving I am.
Sorry?
I am solving this.
Yeah. For solving this, what do you have to apply?
KVL.
Right.
Kirchhoff voltage law.
Right. KVL. So using KVL, since this is just one loop and the current here is given as 2 milliampere, right? So you are entering through this. This is the negative terminal of the battery. So it is -8, right? Then again you're entering the positive terminal. So it is +5. And this is again the positive terminal. So plus Vx equal to 0. So Vx will be equal to 3, right? Yes, you're right. And power consumed will be I into V, right? 3 into 2 milli. Since current is in milliampere and this is in volts, so it will be milliwatt. 6 milliwatt. I hope it is clear to everyone. If not, you can unmute and ask. Everyone getting the same thing?
Yes, ma'am.
Okay. So now you have to calculate the total charge entering the element, where current at time less than 0 is given and current at time greater than 0 is given. You have to find the total charge. So how do you find the total charge? Let me ask. Okay. Twinkle Kumari, could you say how do you calculate the charge when current is given? You can either type it in the chat box or you can unmute and speak up. Anjali, could you speak up? Like if current is given, how do you calculate the charge? Anyone wants to try? You can go ahead. Yes,
Ma'am,
anyone. Yeah,
IDT, integral IDT.
integration
ma'am,
identity.
integral of IDT equal to integration of dV, ma'am.
Yes.
Yes.
So time less than 0 is given, which is 0. That is from minus infinity to 0, charge is given as 0. And from 0 to infinity, it is given 20 e to the power minus 5000 t. So solve this integral. Now it is very straightforward. So Anjali, please solve this integral and let me know the answer. Now it is very straightforward, right? You have the equation, all you have to do is this integral. Anyone has finished it?
4 millicoulombs.
Yes. So, like others, apart from Anand, Bharat, and Gaurav, others, are you doing it? If you're facing any problem, you can ask. Yeah. Anyone has any doubt in this question? Otherwise, we'll move to the next one. Okay.
No, ma'am.
Yeah. So, for another question, a stove element draws 15 ampere when connected to a 120 volt line. So, how long does it take to consume this many energy? So, how are you going to do this?
Ma'am, E is equal to BIT.
Yes. So, the energy is given to you. You have the voltage and current. So, energy equal to power into time. You have to find time. So what is the answer?
50 seconds.
Uh, no, you must have like gone somewhere wrong. Could you check again? So energy is given like 330,000 and power is V into I. 15, right? So it is 100 by
Yeah.
6.
16.67.
And 16.6.
Yeah, right. Seconds. Okay, we'll solve a few of the problems that sir has given in the lecture notes. So let's go to this problem. The previous one everyone has done, right? No one has anything to ask, right?
Yes, ma'am.
Okay. So can you like try out this question? Assume that a 20-volt voltage drop occurs across an element from terminal 2 to terminal 1. Here terminal 1 and 2 is given, right? And a current of 4 ampere enters terminal 2. So through this terminal, sorry, through this terminal current enters. So specify the values of V and I for the polarity difference as shown in this particular figure. So I'll just let me, yeah, I hope it is visible to everyone. So specify the value of V and I for the polarity difference as shown in this figure. Sorry. So anyone wants to comment on this? Okay, let's see. We have, okay. So this voltage that is applied here, it is given as 20 volts. Like voltage drop means like as we go down the circuit, this is the negative terminal and this is the positive terminal, right? So we have a voltage drop across this terminal 1 2. So this v is given as 20 volt. Now current of 4 ampere enters terminal 2. That is to say current direction is in this direction, that is it is coming away from the, like it is coming away from the battery since it is entering this terminal 2. So you have to specify the values of V and I for the polarity difference as shown in this figure, like when for figure A, for figure B, C and D respectively. Like what will be the
So
value of V?
minus 20 for figure A and minus 4. Is that correct, ma'am?
Yes.
Okay.
Minus 4 is correct. Current is in the opposite direction since it is ideally entering through terminal 2. So just hold on. Do we have any? Okay. Okay. So yeah. Since voltage drop is across, I'll just draw it here then. It will be clear, I guess. So this is terminal. This is 1 and 2. let's assume to be V. Now it is written current is 4 ampere is current is entering through this terminal 2, and the voltage drop, that is plus minus 20 volt voltage drop is there. So depending on how it is given drawn in this circuit, you have to calculate V and I. So for the first case, the voltage drop here is 20 volts, so this V will be 20. I is in the reverse direction. Ideally it should enter through 2, come out through 1, but here current is entering through 1, so I is minus 4 ampere.
Ma'am, but the drop is given from terminal 2 to terminal 1, right?
Oh, I see. Yes,
So it
you're
should be
right.
minus 20 for the first.
Yes, definitely. Yes, you're right. Sorry. Since the drop is given from 2 to 1, so 2 is in the higher side, 1 is in the lower side. So yeah. So you're right. For A, it is minus 20 and minus 4. For B, what will it be?
Minus 20 and plus 4 amperes.
Right. So anyone else wants to try for C?
Yes, ma'am.
Yes, go ahead.
Ma'am, the circuit inside the box is supplying power
Yes,
because, ma'am, current is leaving through negative terminal.
and entering through positive.
Yes, ma'am.
So yeah, someone has a comment. Okay, I see. So yes, anyone else wants to comment on this one? Whether the circuit inside the box is absorbing or supplying power? In general, when it is said that any element is absorbing power, when current enters or leaves through the positive side of the voltage. Can anyone comment? I'll,
Ma'am, delivering power.
okay.
When current leaves positive side, it is absorbing power.
So let's say this is a voltage, positive and negative terminal. So when current is leaving through the positive terminal, it is supplying power, right?
Delivering power. Yes, ma'am.
Sorry?
Ma'am, supplying power, delivering power.
Right. So for this circuit, let's just we have to comment on the box, right? So this is the positive and this is the negative side. 1 is negative, 2 is positive, and current is entering through 2. That means it is entering through the positive side. Are you getting it?
Yes, ma'am.
Yeah, so it is absorbing power, right?
Yes, ma'am.
Right.
Yes, ma'am.
Yes.
Clear, ma'am. Continue.
Yeah. Okay, then try let's try. Okay, so huh assume. Okay, this is related to another question, so maybe we can skip this one. Okay, so could you try for this question? I guess you have done a similar kind of question in assignment or from the previous TA, right?
Yes, ma'am. Assignment had this question.
Yes, ma'am.
Okay. So let's like try and do this question. Uh, okay, someone apart from Surya, Anand, Bharat, and Gaurav. Apart from this four, others have not responded at all. Could any one of you, since this is one of your assignment of your question, could you try how are you going to determine the total charge that passes through the element? Would you like to comment? See, just here, if you see, the current is given and time is given. So current is given, time is given, and charge is equal to integration I dot dt. What is integration I dot dt in this curve? Hardik, Raja, Rupali, Twinkle. Can you please comment? When a curve is given, how do you find the integration? It is area under the curve, right? Yes. So, could you quickly find the area under this curve? So I'll just draw it out here. This is 1, 2, 4, and 5. So what you can do is calculate the area part by part, right? Please respond. Anyone? So here t equal to 1 second, what will be the answer?
10.
Right. For
10.
yes. For 3 seconds, what will it be?
22.5.
Okay. So what you have to do is calculate the area under here. Then this will be a triangle. You can do half base into altitude and calculate the area around here. This is a rectangle. And finally at 3, you can calculate here, right?
Yes, ma'am.
Anyone is facing any issue, you can speak up now. Did everyone get it? Please try to respond like others, otherwise I wouldn't know if you are getting it or not. Okay.
Yes.
Okay. So let's try one last problem. Okay. So two electrical circuits are given, which are represented by two these boxes A and B, and they are connected as shown. So for each of the following set of given values, determine the power and state whether power is flowing from A to B or B to A. Let's do like at least one. Like for A, can you guys do this? So when I is given as 5 and V is given as 120 volt, how will the power be? Will it flow from A to B or B to A?
A to B.
Right. So someone has to justify why. Um, those who have not answered, come on. You have to justify this. Why is it flowing from A to B? I have just spoken about this a couple of minutes back. In the meantime, can anyone say the answer of C? So what will be C?
A to B.
Right. So what happens is the current is in the reverse direction, right? So I'll just maybe draw it here. Huh. So now current is minus 10 ampere. That means it is flowing like this, and voltage is minus 480 volt. So it will be plus and minus. So current is again entering through positive terminal in B. That means B is absorbing power, A is releasing it. So it is A to B. Okay, let's see. You guys want to try one more problem before going?
Yes, ma'am.
Yeah. So let's discuss this one. The voltage and current at the terminals of the circuit. Here it is shown. For t equal to greater than equal to 0, voltage is given and current is given. You have to find the power absorbed at t equal to 0.02 second. Let's try the part A. Could you try this? So at t less than 0, it is given as 0. So basically you have to find it from 0 onwards. So 0 to 0.02 second. Formula you know. Power will be P equal to V into I, right? All you have to do is proper integration by parts. Okay, so we don't really need integration here. It is 100 e to the power minus 50 sine 150t times 20 into e to the power minus 50t sine 150t. So you have to find at t equal to 0.02 second. So anyone has got the answer? Okay, we have lots of other questions, I see. So maybe you guys can try this out. Answer is given here anyway. If anyone faces any problem while calculating, you can let me know. Anyone has come up with the answer? Anyone has completed? Um, that's, okay. You will get the content here itself. Uh, I'll just share the. Okay. So maybe you guys can try this out and let me know if you face any problem. Otherwise, we can stop the recording for today. Thank you all. We'll meet in the next